Welcome to the DIY Honda Garage channel. The DTC P04F0 is an error code related to the Evaporative Emission EVAP system, indicating an incorrect purge flow. The EVAP system is designed to capture and store fuel vapors from the fuel tank to prevent them from escaping into the atmosphere. The key component involved in this system is the EVAP canister purge valve, located along the path of the fuel vapor lines. If this valve does not open or close properly, the Pressure Control Module, PCM, detects the abnormality when there is a discrepancy in the expected purge flow, ultimately storing the DTC in its memory. Understanding the role of each part, including the EVAP canister, fuel tank system, and associated valves, is critical for accurate diagnosis and repair. DTC P04F0 indicates a malfunction within the EVAP system, specifically related to an incorrect purge flow. This system includes several key components such as the EVAP canister purge valve, fuel tank, and various tubes that are responsible for channeling fuel vapors. The role of the EVAP canister purge valve is crucial, as it regulates the flow of fuel vapors from the canister into the engine for combustion when conditions are appropriate. The PCM monitors the flow, and if it detects an issue where the purge flow does not meet the expected parameters, it records the DTC in its memory. Understanding the location of components involved in this system can aid in effective diagnosis and troubleshooting. Several factors may contribute to DTC P04F0 being triggered. Firstly, a faulty EVAP canister purge valve could prevent the necessary flow of vapors, which would lead to erroneous readings by the PCM. Secondly, there may be blockages in the EVAP purge system that restrict vapor flow. Any restrictions are detrimental, leading to the incorrect flow readings the PCM detects. Lastly, leaks anywhere in the system, such as in the fuel tank or associated hoses, could also be culprits. Each of these causes can disrupt the intended function of the EVAP system, resulting in the storage of the DTC. When DTC P04F0 is present, drivers might notice several symptoms. A common indicator is the activation of the check engine light (CEL) on the dashboard, alerting the driver that there's a malfunction in the vehicle's emission systems. Additionally, the vehicle may experience a drop in fuel economy due to improper fuel vapor management, leading to inefficient engine performance. A peculiar fuel odor can also arise, indicating fuel vapors might be leaking from the EVAP system, adding to the urgency of addressing the DTC. Together, these symptoms highlight a need for immediate diagnostic attention to mitigate further issues. The first step in troubleshooting DTC P04F0 involves preparing the vehicle for an electronic diagnostic test. Begin by turning the vehicle's ignition to the on mode, ensuring all electronic systems are activated. Next, utilize the HDS, Honda Diagnostic System, and select the EVAP Purge Flow Check Test. This test will serve as an initial diagnostic assessment to determine if the purge flow is within acceptable limits. If the test result is not satisfactory, this indicates that the failure is confirmed, urging the technician to proceed with further detailed inspections to identify the faulty component. The second troubleshooting step focuses on an inspection of the EVAP canister purge valve. This valve is critical for regulating fuel vapor flow and can be the source of faults. Begin by examining for physical damage or any visible leaks around the valve itself, as such issues may inhibit its functionality. Following visual inspection, it is advisable to test the valve's operational characteristics by applying vacuum or pressure using a vacuum pump/gauge. This step will confirm if the valve opens and closes correctly under the expected conditions, paying close attention to whether it retains pressure as needed. In the third troubleshooting step, an inspection of EVAP Purge System 1 is essential. Examine all components and connections of this system for any potential blockages, damages, or leaks that might hinder proper vapor flow. Look for cracks or disconnections in hoses and ensure connectors are secure. Each component must be checked, as any obstruction could lead to the PCM interpreting incorrect purge flow readings. Conclusively, ensuring the integrity of this system is key in diagnosing the overall function of the EVAP system. For the fourth step, the focus shifts to inspecting EVAP Purge System 2. Start this inspection by disconnecting the purge tubes to assess for any blockages. Utilize the vacuum pump/gauge to apply pressure through the system to check if it holds pressure consistently without leaks. Any leakage or blockage will indicate a malfunction within this section of the EVAP system, contributing to the DTC being triggered. As these components interact closely, ensuring their proper functionality is vital for overall system integrity. Step 5 requires inspection of the ELCM, Evaporative Leak Check Module system. Similar to previous steps, inspect for any visible blockages or damages to ELCM components. Any issues detected during this thorough visual examination may likely interfere with vapor flow, leading to inaccurate readings and DTC P04F0 being stored. Ensure all connections are tight and assess hoses for wear, as leaks in this area can compromise the system's ability to seal correctly. Confirming the functional status of the ELCM system is paramount in diagnosing and resolving the DTC. In the sixth troubleshooting step, the main flap unit requires detailed inspection. Start by ensuring the shutoff valve is securely closed, as this step is critical in maintaining correct flow conditions within the EVAP system. Next, assess the flap seal of the shutoff valve for any signs of damage or wear, as this could prevent a proper seal and lead to issues with vapor containment. Ensure that the mating surfaces are not damaged, as they play a crucial role in sealing. Verifying that the main flap unit operates smoothly, with no irregularities, is essential in maintaining the integrity of the entire EVAP system. The seventh step involves validating the fuel tank system for leaks and connection integrity. Disconnect the fuel vent tube and connect a vacuum pump/gauge to check for any leaks that could compromise the fuel containment. Inspect all associated hoses and fittings for any signs of wear or damage that may contribute to DTC P04F0 being triggered. Ensuring that the system holds vacuum indicates that no leaks exist and that the tank's vapor flow path functions correctly. If any issues are found, repairs or replacements may be necessary to resolve the DTC. Step 8 focuses on inspecting the EVAP canister itself. Begin by disconnecting the necessary components and plugging certain ports to conduct a vacuum test. This test determines whether the canister holds pressure, indicating functional integrity. If the vacuum is not maintained, this could signify leaks within the canister structure or any blockages obstructing vapors. Evaluating these aspects is necessary to rule out potential sources contributing to the DTC being set. Troubleshooting issues at this stage is pivotal, ensuring the canister functions as intended. The ninth troubleshooting step pertains to the secondary inspection of the EVAP canister, focusing on potential blockages. Disconnect the components as necessary to check for internal sameness and proper flow routes. Utilize the vacuum pump to evaluate if the canister releases pressure accordingly without obstruction. Inspecting seals and connections for any degradation or failure is crucial in confirming that vapor containment is accomplished. Identifying flow consistency within the canister will assist in diagnosing and rectifying issues leading to the DTC being recorded. The 10th step for diagnostic attention directs focus towards the EVAP leak check module. If other components have been evaluated and are functioning normally, this module is likely the root cause of the DTC P04F0. Thorough inspection of the leak check module is critical, as it may involve specific operational failures that disrupt its testing capabilities. Evaluating the effectiveness and integrity of this module allows for comprehensive troubleshooting, identifying whether it requires repair or replacement. Highlighting and addressing issues within the module directly influences the overall functionality of the EVAP system. Final repair verification is essential after completing all diagnostic and corrective actions associated with DTC P04F0. Ensure that all repairs and replacements were made accurately by re-inspecting components to validate their operational status. Next, run the EVAP test using the HDS to confirm that all system parameters are functioning within expected limits. After successful completion of the tests, clear any DTCs from the vehicle's memory to prevent misleading results during subsequent checks. A re-evaluation of the vehicle may be warranted via a road test to ensure that no further issues arise, confirming the efficacy of the repairs performed. Preventive maintenance is vital for ensuring the longevity and efficiency of the EVAP system in your Honda CR-V. Regular inspections should be conducted to identify any potential failures before they escalate into more significant problems. If leaks are detected at any point in the system, address them immediately to maintain integrity and efficiency. Additionally, keeping components clean from dirt and debris assists in their proper function, reducing the likelihood of blockages or malfunctions. Finally, maintain a schedule for inspection based on operation frequency and conditions to keep the EVAP system in optimal condition. In conclusion, DTC P04F0 is a diagnostic trouble code indicating issues with the evaporative emission system's purge flow. Thorough troubleshooting is essential to accurately identify and rectify problems within various components of the system. Understanding the roles of elements like the EVAP canister, purge valves, and associated hoses is key to achieving successful repair outcomes. Regular maintenance practices should be instilled to prevent the occurrence of such issues, promoting vehicle efficiency and compliance with emission regulations. A proactive approach ensures your Honda CR-V remains in excellent condition and reduces the risk of further DTCs. Please like and subscribe to the channel. See you next time.